platform. I've been at Zillow for, I think, about 16 months now. Very, very much enjoy it. I've had a ton of fun. My one COVID thing that's interesting, beyond the fact that I'm on the second floor of my house, my kids are downstairs. They've been warned not to be too loud, but you know, anything could happen. Makes it exciting that way. Another COVID thing I think is interesting is that since Zillow's in Seattle and I live in Kirkland, I have about an hour commute on the bus. It's nice being on the bus, get to like clear my head out. So I've actually converted that into cooking time. So pretty much the first time in my life, I've actually been cooking for my family all the time, and I'm really enjoying it. So it's one of those nice things sort of Alyssa's getting at. Some of the there's a lot of negative things that really gets us down, but it's really nice things like that where I get a chance to actually interact with I've never have before. So okay, let's get going here. So it wouldn't be the same without talking about our mission statement first. We just changed our mission statement. You can see we're on a mission to give people power to unlock life's next chapter. It really pervades the way we think about Zillow, where we're really trying to help people with what is some of the most complex things you ever do in your life. Like when I bought my house, and I'm sure people bought their houses, I remember looking at it and someone saying, okay, here, sign here, and here's a 30-year loan, and I was like, whoa. And there's so much emotional energy and so much tied into your house, the value of everything else, all these things that to your life. So I really enjoyed the energy when I came to the company, because at the end of the day, it really is about this idea that we can give people information they need desperately, and in a way you can't get to normally, put it all together, not only from the UX side, but also from Zestimate side, where we can get at a really hard question of valuation, which is really difficult. Okay. So yeah, and it's also the people here. I've loved every minute of working at Zillow. It's been amazing. Okay, a few of my colleagues are actually on the call here, so hopefully they'll make fun of me later. So agenda, pretty basic. We'll talk about the Zestimate and Zillow more from the UX and how it's used the business side. I always like to at least get people a feeling for what's happening on the UX side, because we design models. They're all about how they're used and how they actually go all the way up the stack to the very top. Zestimate in production, which is sort of the meat of the talk, all the things we do to make Zest work, all the fun stuff. Some of the articles I saw on the list, things like how to monitor in production, logging, very near and dear to my heart. And then also just a little section on ML at Zillow Group. We have quite a variety of ML techniques we use and applications we use, that sort of thing. Sorry, I'm adjusting a window here. I'm trying to get used to how to set this up. So I'm talking at you, hopefully. And then finally, we'll kick it off at the very end. We'll talk about Zillow's AI platform, more of the process of how we decided. I was talking with Alyssa about this. We're pretty early in our process here, but done quite a bit of work that I thought people would find interesting in how we decided the criteria we're using and some of the ways we thought about it as a business problem as well. Okay, with that, my prettiest picture I have for you today. This is what I work on with my team, right? So we look at the entire United States. We're looking at all the homes. This particular visualization is actually about where we have what we call zestimable homes. The homes that we actually can make a Zestimate on. Now, I should say, and I got to give credit to another, I think it's 10 or 11 teams that get the data to my team. And so again, a system in production is not just about the modeling part, which is super fun, super awesome, but all the stacks of information that come to us in different ways. You may have telemetry or other real-time data, the huge variety of data forms we get. In our case, we have the unsung heroes down the basement, making sure the data coming about counties and houses are getting to us in a way that then my team can start to use. And then, of course, there's lots of interesting bugs we get from this whole process, everything else, which we've all lived with in a real system. We have teams like Lid and Leap and the Zipid team, who just mentioned a few of the teams that actually make my job possible in Zillow. They do things like they match addresses and fuzzy matching. They deal with these concept called parcel, which is the legal entity that actually defines the land that your house is on. And the parcels turns out incredibly complicated. And then there's all the reconciling all these data mismatches we get. We get tons of those as well. Because it turns out virtually any kind of error you can think of, and this is true of almost any system you've ever been in, virtually any kind of error you can think of, actually you're going to see in the different data entry forms. And then, of course, like I was saying earlier, when they can't or shouldn't fix errors for us, because as we know in ML, sometimes we actually want that raw data to actually figure out other trends or other issues. We actually, then it falls upon my team to do a lot of work at the lowest level of the data to get in the form where the models can learn from them. Again, this particular image is of, I did in Kepler, which is a tool I think Uber put together for visualizing data. Super fun tool to play with. The intensity more or less corresponds to population centers. Los Angeles down there, if you take the sort of lower rightish corner, that really intense blob that's saturated, that's basically our biggest county that we have in the entire United States, that sort of stuff. I like this picture because when I first did this particular visualization, I was like, oh, it sort of clicked on how big the domain of what we work on is. Yeah, we have lots of stats that are broken down, and I can see lists of counties and everything else. But I looked at this, I was like, yes, okay, now I sort of get how big it is what we do, and how we affect all those things. Okay, so next, we're going to take, oh, come on. There we are, okay. This is a website that I love and know very well. And I'd say raise your hand if you recognize this website, but I mean, I don't know if we have a vote. Oh, hey, thank you, Jen. Oh, there we are, good, perfect, guys. Thank you. If you haven't, you can go to Zillow.com. I, of course, would not mind if you go there. I, in fact, like that. Those are all, anytime you can. It's a great place. Now, one of the things we did first with the company was to actually make sure you have all kinds of information you can't get in one spot in a nice format that's integrated in everything else. This is already an innovation by itself. But of course, one of my favorite pieces on this page is, of course, the Zestimate. One of the big differentiators for the company from the first day the company opened in 2006. So the Zestimate is that piece up in the upper right-hand corner. This is actually, this is a house I know pretty well. I live in it. It's the, I've tried to obscure everything so you can't come visit me, social distancing, etc. But yeah, that's I know a lot about this house, which is nice. I'm actually in the second floor. You can't quite see it from the picture. Oh, you sort of can in the picture, actually. I'd wave, it wouldn't help. So the Zestimate in general is the estimate of the value when the home is off market, especially in this particular page. We actually have an on-market model as well. I'll go into that a little later. And it's generally computed in the basic sense of your home and other homes that are like it and the sales prices they have. If your home hasn't sold for a while, that's generally how we learn that's a response variable. That's how we actually learn the models, our nonlinear models. For the most part, and that's a gross generalization and trivialization of what's happening, but that's the core basic principle of the system. I shouldn't be surprising at all. And then just below the Zestimate, which is that $1 million number, is the Zestimate range, just below to the left, lower left. That is the range we're talking about from the model uncertainty. It turns out straight through from the system. And so that gives us our PI for this particular estimate we have. We use that. It's interesting trying to communicate that to the user, what that really means. It's not like we really can talk about it in the classic machine learning sense. And so it is interesting with Zestimate because it's exposed directly to users and how we have to really work hard in our language to describe it and try to make a mapping that preserves the importance and the discipline that went into creating it without actually getting a language that people don't understand. We don't talk about distribution and all those good things like that we know and love. You also see at the bottom, below it, you'll see the history graphs down there. There are 3 graphs, my home value, which presumably is going to go down, but we'll see how it works out. There's also this some other regional data that I'm not going to name where it's at, but talk about, and those are trends that are coming from ZHVI, which is our, there's an Zillow has an economics team that actually produces an index based upon at least one input is the Zestimate itself. And so at that point, they look at broader regions and they can do some projections to do quite a bit of sophisticated modeling, as well as projecting a variety of things internally for the company as well. The interesting about the histories down there is that history is actually brings up an interesting question for our users, and it relates to modeling as well. That is not the history of what the Zestimates produced since 2006. That is a recomputed model history of what our current model version actually predicts for a value in 2009. That's probably a relatively obvious conclusion from building models, but for the users, it's an interesting question. They often look at it and ask, well, just a second, last week it looked like this, and then you did some wizard thing with your models, and now it changed. It's an interesting sort of conundrum in there because I think we all understand both reasons. It's like, are they trying to, when it comes to a value of your home, changing it is actually not a minor thing for our users. It really has impact on them, yet we always strive to have the best algorithms and the best training we can. So finally, this page represents the primary data for a home. This is sort of from our traditional search and find business, which is come in, find a home. If you're interested in buying it, go see if you can connect with a real estate agent, right? That's been our business up until probably 2 years ago. We started looking at 1.5. Started looking at doing this iBuyer experience. Well, I'll touch on a little later. But the Zestimate plays a very important part overall, attracting customers to the site. So for the business, there's an interesting question. Is it basically at a fundamental level, it helps us keep our customer acquisition costs low. That's an important piece anytime we build models. We build models for these purposes. In our case with the Zest, it's pretty obvious what it's going to do, the value statement, and its ability to actually make sure we have this unique entity that brings our customers in reliably, keeps that cost low, keeps our costs down from requiring, especially when we build on secondary initiatives like Zillow offers. Okay. So speaking of Zillow offers, so I'm not on that team. I talk to them occasionally. Great guys and ladies. One of the things we try to do is put a number on every roof in America. We really want to say, if it's a home, we can give you a valuation, a pretty accurate evaluation. That has been our goal since before I came to the company, obviously. Now, at that scale, at 100 and something million homes, it's really about minimizing error at the national, state, and county levels. That's the entities we think about. That's how our metrics are built. I'll do some metrics later on. You'll see what they look like at least a little bit. But as with any model, of course, we're going to have errors, right? Especially at 100 million. With that multiplier, we have enough errors. And we have eyeballs, people, who are like, that's their house. This is not an abstract question to them at all. For me, it's an abstract question. Like, yeah, it's hard. They don't really buy that explanation, much as I try. And we have a lot of fun with the customers coming in. We try to really help them out, but unfortunately, there will always be people who are not happy with the Zest that they're getting for various reasons. So it brings up an interesting question for us. Where the system is doing 100 million, how do we debug single issues? Right? I got a customer; they're upset. Puts a ton of stress on our tooling when we're trying to cover both these high-level metrics, everything else, and then pulling it down to like, let's debug that home, exactly what went through the model. These are nonlinear models, so they're difficult to debug anyway. And then we have that whole stack of data I mentioned earlier. How do we actually deal with the fact that the data, it could be anywhere in the stack? And this is a normal problem we all face in complex systems. And as with any system I've worked on, including in Microsoft, I don't have the tooling I want. I have trouble tracing down on the 15, 20 layers of issues that might actually affect an estimation, where it's at. I have nothing, unfortunately, to say other than, boy, it's painful. I'm sure people out there are nodding their heads that, yep, that's what my system's like too. Or if you're lucky, you're like, no, I have everything locked down. If you do, please tell me. I'd love to hear how to do it. Okay. Now, again, Zillow as an iBuyer changed that story a bit, right? I just got through saying, yeah, you have an error. That's too bad. It's interesting when you get to pricing errors when you have, say, we have pretty broad error tails in some cases with our errors. If you're trying to buy a home for that value, suddenly it becomes existentially important you don't have those errors. Now, the Zestimate is just one small part of an elegant modeling system that the Zillow offers guys have put together. But it does play a role, and we're definitely looking at this transition, trying to understand exactly how we can make these systems more accurate, and more importantly, how we can characterize where our model uncertainty is actually leading us astray. Okay, now, so these are the metrics that come from the Zillow website. If you click on that link below, you get the actual the Excel spreadsheet. It's actually Excel. It's pretty funny. with these values and more values about these things. I'll give you a little tour of these values, and we'll start up with the top there, where you see national, type, median error, those things. We have two classes of models, and I alluded to them earlier. There's the off-market model, where you're not actually for sale right now. Your home, like my home right now, it's sitting here, not for sale. And so in those cases, our national median error, our MAPE, is actually 7.7%. Now, that's we can have lots of conversations about how we measure that, how we aggregate it, but 7.7%. So that's a fairly large number when it comes to like a house my size. It's actually a appreciable amount of money. We have 97.5 million homes that we actually are zestable, like I said earlier. So we can actually, yes, let's go ahead and we can actually do it. We have enough data. We think we're enough quality to actually do it. And you'll see the within 5% sell price, 10% sell price. Sometimes internally we refer to that as PE5 and PE10s. But yeah, we get 36% of the homes when we actually evaluate them are within 5% of the sales price. Very hard to achieve. This is a decade worth of work to get this point. On-market model, introduced that mid last year. That model has a median error of like near 2% here. That's interesting because that was the first time we directly used the pricing coming from a real estate agent. We had to put a lot of guards in there to make sure it wasn't manipulated by people, because we don't want people to be able to play with it and move things around. And that one's interesting because you'll see the homes with estimates. That's 1.6 million. That's a pretty good number because it turns out about 1 to 2% maximum are on sale at any one time in the United States. So if you think of the inventory of all the homes in the United States, 1 to 2% are actually on sale at that time. And then I really love the PE5s and the PE10s here. So 83.7% of them are actually within 5%, 95% are within 10%. Now these values are typically coming from your real estate agent who's going to sell your house, and they'll do the initial estimation with you. They're positively biased, which is an interesting statement about real estate in general, that they're listing a little high. This is sort of the outcome there, right? I have lots of pet psychological theories why this happens. I won't go into them because they're pet, but nonetheless, it's interesting. So our model mostly corrects down, but it's a model that will correct either direction. So if you risk really low, it has a tendency to actually push your value up and say, yeah, you're likely to sell for this. It's a very, I'd be really careful how I type the language about likely to sell. That's a rather loaded term. Below that, you see some cities I selected. We have more cities that we actually break out stats for. But there's an interesting thing here. I didn't pick them randomly. So here, the highlighted entries, if you look at the values, you'll see that like Denver's at 5.5, Los Angeles 6.1, 7.3 for Miami, New York at 9.5. New York's a hard one. They have a pretty inhomogeneous set of homes, right? So older construction, some are renovated, some are not, some are renovated very high end. This obviously throws some wrenches into the work for the models, finding similar homes to actually comparables, and actually getting the pricing right based upon the fact that we train from similar sales to your home. Now, then we see Orlando there, Phoenix, Sacramento, San Francisco 7.2, which means you can see again that probably an interesting set of population of homes with a lot of variance. And also their sales strategies are a bit different there. And then finally, good old Seattle, King County, yes. So you'll notice that the blue ones look like they have generally better MAPE. And while these lower MAPE scores are not sufficient for us to move into a market for Zillow offers, it is certainly the case where these are rough indicators that we have the data we need, and that we actually have likely have the right conditions, at least for the modeling side of the house, to actually go in and actually think about purchasing and selling homes. I'd love, maybe someday we'll get the Zillow offers guys to come give a talk here on all the work they've done to actually do all the rest of the really hard things that I'm just brushing over here. So with that, we're gonna, oh, my phone's going off, how fun. We're gonna go ahead and actually drop into Zestimate in production, which is something that I had, so like I said, 16 months ago, I came to the company, and I had the joy of diving in the deep end. It's been an amazing experience learning about this. As Alyssa probably alluded to a little bit, I mostly did I did NLP for almost my entire career. It was really interesting moving from classification and sequence labeling tasks and those sort of situations, moving into purely regression techniques. So with that, a little bit of history here. about the model. Let's see how we're doing on time here. Back in 2015 was the last model that was done on using in-house on-prem hardware. We call it the Z5 version of the system. At Zillow, everything's prefixed by Z. When I used to work in the office org in Microsoft, it was always O something. I always loved how we get out the first letters on things. So 2015, it was mostly R, a bit of Python, and almost all in-house tech, including this parallelization library, cool parallelization library, but closed source, all the normal issues you get with that. And we didn't really have MLEs and not a whole lot of SDEs, so there's a lot of statisticians doing the coding. The current system, which, depending on how fast I can get the AI platform running, so wish me luck, is good running through at least next year is my guess. But regardless, mostly Python based, but a fair amount of R still in this code base. The direct write to S3 and Redis systems, we don't really have anything that backs us off from those systems or insulates us from issues like that. If you've dealt with CCPA or GDPR, you know that, boy, having raw access to your data lake is actually a nightmare. So we've dug our way out of that as well on the Zillow side and Zestimates, of course. It's been amazing to watch people do this, but it's been quite the journey to get through that. In Microsoft GDPR, it was even more amazing. The tooling, even alone, some of the boxes we had to deal with. And then the framework, yeah, it's Apache Spark based, although a little later on I'll talk about it's a bit of a hybrid actually. Finally, where we're going next. And I'm going to try to, like I said, I'll talk a little bit at the end about this. But try to get all the Python now, get rid of the last R code. We love R, but we don't really want to use it in our code base to support it. Data storage, we need a layer that's going to actually give us a lot more ability to track and do lineage around data, right? So Zest doesn't have any PII in it or any kind of link information in it. Nonetheless, I would love to be able to use some signals like that if I ever got a chance. Make sure we actually get the governance correct, everything else. Compute, note the compute there. It's a little strange to say compute is Kubernetes. That might give you a little bit of a clue about where we're heading in terms of our platform. Then the framework, well, again, wish me luck. Hopefully we're going to get this AI platform running. I think two of the PMs I work with, great guys, are actually on the call, so hopefully they're cheering right now. Okay, let's talk modeling scale for a second. So this is one of those things that's interesting. Up until this point, for me, my experience was that I dealt with a few hundred models at most for those things we're pushing out. Some of the proofing stuff I've done, we're looking at putting out 100 and something models simultaneously. And I was like, boy, I'm where it's at, man. Look at me. Look at my team. We're amazing. We actually have 3,600 counties we approximately calculate, and that's as map is of that. We have ensembles with about 10 models per county. We train and score these models and push them in production daily. It's amazing. So without a hitch, we push out 36,000 models. It goes to our request batch, our non-batch system, our speed layer every day. It's the fact that it runs reliably every day is sort of a miracle sometimes, I think. Of course, in a real system like this, we hit all kinds of glitches with S3 being flaky, sometimes our own software is flaky, timeouts, Spark issues galore, all those things. So, but that's why we think about this problem is a whole bunch of counties and mostly model at that level. We've tried various different partitionings. The scientists would love to get at a different kind of partition, like something more dynamic and learn partitions for where the right boundaries are for valuation. All those kind of things. And of course, in a big system like this, that's pretty hard for us to change the primary partitions. Okay. Now, one of my favorite diagrams. You'll note that there's some missing labels in the middle. That's on purpose. Your monitor is still working. What's going on there is that there's a lot of pieces in here that I can't really disclose in this kind of meeting, unfortunately. I wanted to give it to you guys, like, but not so much. But I can do a little bit. I left some labels in that are at least give you a little like taste of what's going on. The bottom layer there in blue now is actually our cleaning layer. So I talked earlier about all the heroes that got the data to me, right, and my team. From there, we then get ready to actually do a lot of second order operations. We have a lot of transactions. They're duplicated in many cases. There's errors in them. So we're doing a lot of the classic error reduction at this stage to get it ready for the actual training phase. That whole subgraph down there is different versions of getting things ready for production. So we have for production training. So we have the cleaning the transactions. We have cleaning the listings. Pardon me. We have cleaning home values because we get a lot of outlier problems because these are all done by humans. And finally, we have imputation, right? So we have to fill in the blanks for a lot of values to make sure we can actually then put them into our nonlinear models. Pardon me. Then, is that showing? Okay, there we go. This mostly blank box set is where the primary ensembles live. So the different there's a bunch of secondary ETL processes in here that feed into the secondary set of models, which are then finally combined up in the stack up there. In this case, fairly traditional architecture, but it's all combined together in this one giant DAG that is meant to help us actually modify the system and control the system. Then we finally have our output layer. Now, we have our on-market model and our off-market models outputting. We have to resolve which one actually is the Zestimate, because there's only one slot in the UX for it, so we can't have both. It's very confusing to users if we actually put both on there. You can't actually get to the off-market Zestimate from an on-market page if you have to, but we didn't want to go through the process of trying to explain to users. There's two kinds of estimates, and they have these flavors and these characteristics. Took about 2 months to resolve that question, actually, to the UX side. If you've ever dealt with UX and modeling and how it comes together and try to explain these things, it's always a really intensely fascinating process to get through the whole thing through the entire org. Again, models in production is all about this. So this is a lot of business logic up here as well. We have a few spots we can suppress estimates, and that's specified up through here. This is the graph that the scientists see. This is the workflow the scientists see. This is in a giant, fairly scary YAML file. A bunch of parameters. We have the classic problem of a system like this where some of the parameters about a particular stage are actually in a different section of the YAML file. Some are localized to it. Classic engineering you get. Classic problem of like which way should you slice your configuration data. Fully present. The scientists have to interact with this thing also directly. Constantly editing it, constantly trying to figure out all the merge problems you get with a normal YAML situation. Still, it was a step up from the older system. So this is the primary DAG that we use day in, day out. Okay, now, this is your classic Lambda architecture. Zestimates started out life that way as a Lambda architecture in 2017. So you can see the classic process of the upper left corner in the orange is your classic situation where you're actually going ahead and actually do your map reduce process, get your data ready. Then we start the blue boxes, which are the core batch process for Zestimates. You can see the data cleaning, imputation, ETL logic. That graph we just saw directly is isomorphic with this. There's more details in the previous graph, but this is the actual underlying system architecture we talk about. The rules of the outputter logic. We have the ETL process to create the Redis cache, all these things. I won't read the whole thing. Upper right's where our speed layer is at. So straight out of the 2015 big data book. Right here. And then our serving architecture that we go to the front end with. So, good. Big high level view. This is about as low as I can get in the details. I would love to go to the next level down with you guys and talk about individual models, how they're built, how they're trained. That's the kind of stuff, unfortunately, I can't get out. You know, those Redfin guys, they're actually too good at what they do. Okay. One of the important things when you're dealing with real estate and the sparse data we have is that we have to actually be able to actually measure our models over time. We don't really have enough transactions today or yesterday to retrain our entire model. So we have to be able to support a total notion of actually understanding what homes were like over time, both the transaction data, and also to validate the model that it's behaving properly on previous regimes, so that hopefully when we get into new market changes and market shifts, our model still generalizes as well. So that graph you saw earlier of the home value, you'll see almost everyone has a dip after 2008, 2009, surprise, surprise, and then that slow rise, and then the more recent uptick. We make sure our models work today as if that might happen. And so given COVID and given what's happening with values right now, we're actually spending a lot of time, again, making sure our models handle a very unusual regime of real estate and marketing changes. So this particular diagram is showing how we actually can keep all these facts immutably over time. So we store all the facts. Scientists can actually select what they want to do with it and what kind of time slice they want to use. They want a 3-year time slice, a 2-year time slice. They want a few months of time slice. So if you think of the scientist experience, they spend quite a bit of time thinking about how big of a range they want to look at, and also how many counties they want to. So you have those 2 dimensions going on. This also turns out, in terms of trying to actually validate our system, I'll get this a little later, that it's pretty pricey to do experiments on the whole of the United States simultaneously, especially when you're doing it across the United States over 10 years. Those are where I get a lot of nasty emails from folks saying, you just spent, I won't say the amount of money, but enough to be noticeable by a lot of folks up the chain. So that's part of it. When you get into build platforms, one of my questions becomes, can I make it easy to experiment? My next question becomes, can I spend too much money too easily? Okay. So yeah, pretty classic Lambda architecture in terms of what it's doing. Almost all the interesting details are in how we actually do the data processing pieces and those underlying model training and validation pieces. But yeah, we do a lot of training across the various geographies, like I mentioned. Pardon me. And this is the full layer where the 110 million homes get scored every day. Finally outputting to the data lake, and we'll go to that diagram in a second. So yeah, every day, the database guys are very happy. By very happy, I mean they're not very happy that we scored out 110 million 40-row elements and say, now please get that onto the site as quickly as possible, and then repeat the next day. Speed layer. Okay, so typical Lambda architecture, we have a separate speed layer that is not the same code and not the same science code for sure as the batch layer. This is always interesting, which means we have 2 limitations of our runtimes. That whole ensemble thing had to be written twice now. Any business logic that's on the science side is replicated somewhat with some interesting gaps on the speed layer side. This is a major L. When I think about what it means to build a platform, I have to get rid of this situation. I think we've all, if you've built these batch systems where you have an asymmetric system like this, I'm sure you've felt this pain as well. We have the classic speed layer to correspond to changes. So a user comes in, or we get data from a county or whatever else. We actually want to be able to update it in that day, hopefully very quickly. Our speed layer today is almost completely concerned with dealing with listings coming in. So you have a home coming up on market. We're going to have hopefully a whole bunch of people wanting to go to the site immediately and saying, what does Zestimate think about the price of this home, right? That's the value statement we want to have. Our speed layer is primarily these days is about that. New listing comes in, make sure you get the estimate out as quickly as possible, within minutes, I hope, and get it all the way back to the rendering on the front end web page. And you'll see why that'd be sort of interesting in a second when you see the next piece of the system. And the homeowners update facts, which is always interesting. One of the amusing asides for that one are that homeowners have a tendency to think, oh, I want to remodel. I'm going to go and change my bedrooms on my house on Zillow to 3 now or 4 now. Sometimes they forget to undo it. And so we end up saying, oh, well, your house is worth this more now because we trust you. So this is something we see where there's always an interesting question in our underlying metric story about, hey, what is the accuracy? Can we model the accuracy of what users are doing and weight them better in terms of understanding, is this an error? All those kind of classifiers. We've never been able to carve out the time for it, but it's an interesting problem we end up having where people can actually change the homeowners can change their stuff. We've thought potentially we have to actually build a different mode where we say, here's a tool so you can play with your home. Oh, have 12 bedrooms, I don't care. Rather than trying to actually modify what you think your home is. Okay, or what we think your home is, sorry. Okay. Speed layer architecture. We get events from a kinesis feed, pretty much standard. We're trying to move slowly but surely into Kafka-based systems. Get something more classic with pub/sub. Hopefully the next generation will be pub/sub based off of more Kafka-based systems. We have the Zestimate API, which is that layer I discussed that actually tries to partially replicate the full batch behavior of the system. And finally, our trusty Redis cache, which costs too much money, but we need it, where we actually place a subset. I believe that one is the 40 columns per home in there, just in case we need to recompute a value. So we have, again, we have all of America sitting in our Redis cache. Serving layer. I was surprised to see a SQL database. When I came to the company in 2019, at the very beginning, I was like, there's a SQL database in your system. What happened? Now, I should say, it isn't like at Microsoft, I didn't have a ton of legacy systems that I had dealt with, and actually, unfortunately, created myself, and sometimes was responsible for, even after a decade, amazingly enough. So that's what it was like being Microsoft. So I get it; it happens. Totally makes sense. So our system is we drop in these different buckets. The date key referring to the date we actually do it on. We have a latest build, which is a concept I've always hated in systems. We're saying, here's the latest build. I've always hated that kind of system. All kinds of bad behaviors. People can comment later if they don't agree with this, but latest always generated bad behaviors, and people, they look at it, it updates in the middle, you get all kinds of striping issues and other stuff going on, having latest. But that's what we use. People are used to it. We have a lot of legacy people who want to point at latest. And that gets partially pushed to our Redis cache. It's not quite like that, but where we actually push our every day we update our 100 million homes worth of Redis data. A secondary push goes to the SQL server, which is really a staging area. It has two primary tables we care about, which is the static Zest data, and then the update stuff coming from the speed layer. So either user changes it or a listing comes in. We push that through the SQL server. It has a bunch of triggers that actually hit what's called the Pogo cache. That's an in-RAM cache that was built in Zillow. It's actually quite elaborate. It's a bunch of C++ code, which is fairly interesting to watch because we have a whole bunch of Python devs who are like, oh my gosh, C++ code. My background is mostly C++, it turns out, back in the day. So I'm like, oh yes, C++, yes. Hope someone out there might do C++ with me, we'll see. So again, and then there's a fairly simple reconciliation layer for when we actually have both a Zest estimate and we have this updated estimate. It's based upon, as you can imagine, the date stamp. Very tricky. Mostly it's a matter of actually getting the Pogo cache and its latencies from the database over into that cache itself. So pretty typical architecture that way. You may not recognize all the pieces, but that's all right. It's recognize the underlying patterns. Batch deployment. 6. Okay. I wouldn't be complete a story like this without actually talking about how we build it. Right? We factored pretty heavily in the first version of this. So we have 30 plus Git repos for all the different little pieces coming together, which is great. It was not so fun when we went to go from Python 2 to Python 3. Suddenly, for the first time in a while, we had people like, I got to modify all the repos simultaneously, get them all pushed, get them aligned, get them going. I had a lot of grumbling on that one. It was pretty funny. It's always a trade-off with these things, how we partition our code bases and how we ship them and package them. We have a two-stage build. We build the code out, which mostly putting the eggs together, getting them ready. And then we push it off a whole secondary process to actually then provision the EMR cluster. We moved to, we originally had reserved instances we used on AWS for this. Then we moved over to using on-demand nodes instead to give us, because turns out, as we were modifying the code and trying to get more and optimize our compute, we started hitting a situation in which we didn't need nearly as much of the time. So I don't want to get real specific about how long Zest takes to compute, but there were times we were running 18, 19 hours to do all of the United States. I think we're running more like in the 6 to 8 hour frame these days. So we no longer needed to actually keep reserve instances. We could actually save some money by going to on-demand. We actually did make an attempt to go to Spot. Unfortunately, our system isn't resilient enough to handle the nodes going down. Spark should be fine, but we use a custom system called the Zest driver, and it doesn't have all the retry logic we need to actually handle all the edge cases we get. Other than that, we've used our node counts are range, so I put n nodes. We've sometimes up to 30 nodes. Reasonably heavy compute nodes. Now, why I said hybrid a while ago. So if you think of Spark and you think of maybe MLlib, which is their natively parallelized version of Spark's machine learning libraries, we don't use those libraries. We use a custom library I can't talk about for our core trees that we build. That particular library, since we do county-based systems, we actually distribute using Spark to the point where we say map partitions by county, and then we drop it onto individual nodes. So at that point, Spark is mostly just actually being the actual job scheduler for us, which is that's a great job of this, of course. And then each node at that point effectively transitions into your a data frame, and then you start computing that county's data. So I mentioned, LA is our biggest county. We basically we need 30 LA-sized nodes in our machine today, in our cluster. Because any one of those nodes could have LA on it, where we have our models hit their peak size. It's an interesting consequence of not being able to right size and dynamically allocate it. So a bit of a partition, a bit of a hybrid. Okay, so now, someone mentioned earlier on the list, on the chat window, logging and metrics. Obviously, a system with 110 million homes, we can clearly do a lot of fine-grained logging, but that logging itself would be overwhelming. So instead, we have quite a few aggregate metrics to make sure our product is healthy. I selected 15 of them here. This represents, I think roughly we're computing about 100 different metrics a day. Just give you a rough feeling, I think it's 80, something like that. And things like, if you take a look up there, you have like estimate count, published, Zestimates, model percentile 10. These process metrics are all inside of our ensemble process. So we're making sure getting a bit of an X-ray and optics into how the ensemble is working. If we have trouble we occasionally get bugs in the ensemble process, but not in the overall stack model or above that, right? So you saw the graph. It has that DAG. It has, I think, 45 currently nodes right now. With all the kind of concurrent execution and other intermittencies, having some notion about where things are going wrong interior to your process is very important. Anybody who's ever developed a large-scale system or even moderate-scale system has hit these issues and understands the incredible pain if you don't have the right optics and kind of logging and metrics in your system. So you see the process metrics, accuracy metrics, which are what we mostly talk about outside. So that's where you're we actually talk about what's our actual, effectively what's our MAPE on our sales pairs. I put prediction versus actual. That's not the actual name of the metric. It's sales pairs, but not clear people would understand what sales pairs meant. And there's good old NPE, which is we use mostly a measure of our model bias. That's the median percent error. So that's a summation of all the percent errors across all the model performance across the county, national, and state level. That should roughly sum to 0 if your model is well calibrated and actually not biased. Positive or negative bias would indicate that your NPE is above 0, or negative bias, you're sort of underestimating versus overestimating. The MAPE, that's the median absolute percentage error. So it has the absolute in there to make sure we understand the magnitude of errors we're making overall. And that's that 7.7% I quoted above. That's the MAPE. AAPE is a much harder metric for us to drive, which is the average absolute percentage error. So this is an interesting metric because it really talks about not the median, of course, which is where we have most of our data. And this is where we start talking about all the outliers showing up. So these really expensive homes, very, very inexpensive homes that don't have a lot of comparables for us to actually model with and find the right answer for the end customer. So AAPE, however, it becomes very important in our tail analysis, our tail errors, when you get into regimes where you're talking about, say, offers again, where, boy, those are where the things that are come and bite you live in the tail errors. So having a high APE suddenly became very important when we started thinking about how do we help out offers from the Zestimate side. APE is the average percentile error. That one, since you have the different magnitudes, you have a negative errors and a positive errors, it has more of a tendency to cancel out. So we like to really track AAPE, but the other one's important as well. Stability metrics. Users do not like the value of their home changing rapidly. Right? So we're sitting there, and if my house changes 10% value a day, I am going to be very upset, and it's worse than useless because now I don't understand how to trust your system. So we work very hard to make sure our day-over-day changes and our month-over-month changes and are all within a certain ratio, what we call shock levels. Shock. We don't want it to shock too much for the end user. We want to make sure people can trust the system, and it shows that our modeling has a reasonably smooth behavior going on. Now, with COVID, it's interesting to watch because I do expect as we see data that we'll see some valuation dropping in a fairly radical way. It's not a very hard prediction to make. There are some questions about also the fact that we expect transactions to dry up. So that since we use transactions to train, it's sort of an interesting question about how accurate our models will be over the coming time here. My science guys, Andy Krause is the science manager now for Zestimates. They're spending a ton of time trying to actually characterize what scenarios what scenarios will actually happen. Recovery shapes, so down and long, sharp V, all those things, and then running the whole system multiple times to actually predict what those look like. They use that aforementioned ability to time travel to do these metrics across all those time regimes and modeling regimes to give us a feeling for how we'll respond, especially how we respond to recovery, because we want to get back in the game as soon as possible. The bottom there is a little diagram of our metrics models. This is mostly a separate system that we use. We have an internal product called Luminaire that we use from our data engineering team. And we drop our data in there, and then of course we go to a variety of different endpoints to monitor what's happening. So you see Tableau in there. Very typical kind of monitoring, nothing special there in terms of the monitoring we're doing in the way we visualize it. We have other things we use for more of the science-directed monitoring and visualization, but it's not as well developed as these pieces. So yeah, we watch these all the time. We have tons of alerts set up, different thresholds. We don't have a lot of automatic anomaly detection. So we've had cases where, for instance, data in a county is dropped to very low levels. It takes a while to propagate to us. It comes through, and we eventually see a bunch of customer complaints. We come back, we're like, oh boy, that county has a reporting problem. Counties vary wildly in their quality. There's a particular county in Virginia that's well known amongst assessors for being extremely high quality. So the Zestimates there are very high quality as well. I always think it's interesting when I start talking about tax assessment because 2 years ago I never would have envisioned myself being now fascinated by tax assessment and how it works and the value it gives and how accurate it is, these sort of things. It's great fun driving into the domain-specific aspects of the whole process as well, and how it affects data quality like this and overall system behavior. I'm trying to figure out how many folks, has anybody heard of the Z Prize, the Zillow Prize? Okay, there you see. Thank God for Alyssa. Okay, so we did looks like Sam might have said yes. Good. We actually did a competition on Kaggle. I'm sure you heard of Kaggle. If not, that's a place where they run all kinds of machine learning competitions. These are like ninja machine learning experts. They know every trick in the book plus 10 about how to actually make models quickly that have very high accuracies. Ensembles are pretty much the rule there. All kinds of in very sophisticated combinations. So what we did is we went through. We had $1 million prize to beat the Zestimate. And of course, what we were interested on our side was, hey, give us techniques that we couldn't explore. Right? Here's $1 million. Let's see you explore featurization techniques, modeling techniques, other techniques that we can't explore. Now, Andy Martin, the forum manager of the Zestimates team, science team, he actually designed this after looking at how Netflix did their experiment. Now, it was interesting. What ended up happening is that Netflix did the experiment. They had some trouble reproducing the results. So Andy said, aha, everyone will deliver their results in containers. So super cool, got the containers. Then the fun really began because, of course, each of those Kaggle, these are only top 3 of the top 15 or so that we looked at and talked a lot, had to go reverse engineer. I mean, they did tons of documentation, probably the first time that Kaggle had to do this, but tons of documentation. We still had to go through and reverse engineer the techniques to understand, could we apply them on our current system we've just gone over? Now, it turns out it's relatively hard for us to add new model classes to our current system. Historically, there's a reason why, all those good reasons, legacy, blah, blah. So we had to do quite a bit of work to adapt it. The featurization techniques, some of them didn't work with our modeling regime working. So all those things, we got a ton of value out of it, but it was very, very interesting to actually take that process. If you're doing a really large scale system and you want to actually incorporate these kind of interesting inputs, it is very hard to design an experiment where you could talk about how to apply it easily. I don't think that's a particularly surprising outcome, but it is interesting when you think about the overall, how would you actually design a system to take this kind of external input, or should you even try? Okay. ML at Zillow Group. As you can imagine, and I'll give you a few examples here coming up here, we have a huge variety of ML techniques we apply and areas we're investigating at Zillow. So of course we have my favorite, and hopefully everyone now is like, Zestimates is the best. It's so awesome. Okay, good. See, I'm seeing some smiles. That's good. Some converts here. We also have the personalized recommendations, recommender systems, of course, a huge sort of area in the system tying in with user behavior modeling. Those are our recommender systems that are built are responsible for some very, very, very strong gains in the top of the funnel metrics for us in terms of getting users in and keeping them in the system, right? So this is, I mean, this is not unusual, but it's really nice to see ML models at scale responding near real time that are actually, you just see that immediate value statement of what's happening. Premier agents, well, hey, that's what pays the bills. Premier agents are the folks that are our agents that actually pay us to actually get connected up to customers. So we work very hard to actually route customers correctly and reliably and quickly to our agents. We do a lot of work also to understand how agents are performing and how they're doing. Whole bunch of modeling there too. Whole bunch of behavioral modeling, all the things you'd expect. Now, virtual tours. With COVID, suddenly virtual tours they were important before, now they're like incandescently important. How can we actually give people the opportunity to buy a home right now? You don't want to risk your life, go out and get sick. You don't want to make anybody else sick. So virtual tours, panoramas, there's an entire team that actually is spending, really working, I wouldn't say around the clock, but they've definitely pulled a lot of their modeling and deployment of models in from what have been their previous schedule to try to get virtual tours even better and more quickly out into the market. Zillow Offers, I talk about Zillow Offers. Rather important effort. I don't even exaggerate how important that effort is to us as we become an iBuyer and try to really cover the full life cycle and make it, not only do you know more about your home, so for me on the informational side, I tell you about your home and tell you about values, but now we can actually do a really good job making moving trivial. If you've moved, bought and sold homes, it's amazing the process. I like to talk about this term called perpetual amateurs. At best, buying and selling a home, you're a perpetual amateur. Most of the time, you're just a pure amateur. I certainly am. I've learned more about it, but I still don't have that kind of like knowledge and like comfort in doing it. So Zillow Offers, that's our ability to actually make that process really work for you and make it as streamlined as possible. And we have a few other things here. We have a unit that does home loans, originates loans, and actually does a lot of modeling there as well, on here as well, but they're another awesome team that we work with. We have a bunch of teams that actually are working on things that are fairly prosaic but extremely important. Like, boy, we have a ton of paperwork coming in. How do we convert that into an electronic form reliably, quickly, and then also do the information extraction task of these are the pieces I need out of this 84-page document quickly. You can imagine those kind of tasks all the time. Conversational assistance. We have a team that's actually working on doing conversation assistance. So you can be the scenario, I'm in my car, I'm going to go look at a home. This is, of course, don't go in until COVID's done, but you be in your car, you can ask it questions. Hey, what about this kind of home? What about that kind of home? Where's it at? All the kind of things you'd like to do. That effort's pretty nascent, but it's also very clearly a situation that my other half of my life, the AI platform piece, we want to make sure we can get those guys hooked up with the NLP pieces. I'm pretty excited about that because I love NLP too. So, okay. With that, how are we doing on? I think we're still all right on time. I think if we're like 8.
It's 6:42, so yeah. I just want to make sure we leave out time for questions.
Yeah.
But I don't want to cut off your talk because it's really interesting.
Okay, let me try to pick up the pace here. So I don't think I'd be surprised if anyone says modeling velocity does not equal business velocity. Very clearly, for us, one of the big motivations for the platform at Zillow is that it is the case that as we respond, especially when the market's tight and we have a lot of different competitors, this is how we're going to make a difference in our respective industries. I think we all know that there's lots of problems. I'm not going to list them here. This is one of my favorite articles. It's pretty old now. This is from the classic Hidden Technical Debt in Machine Learning Systems. This is the classic point that people spend way too much time not working on the ML piece, right? The whole, when I go into this Zestimates graph, unfortunately, when they edit they're editing 15 different places, they're playing around with deploying it, they're doing all the things they shouldn't have to do. So my central thesis for how the platform should work in the future focuses on workflows. I think workflows are our core piece, bringing the workflow back to the scientist, where they work on the workflow as close as they can to the code and to the actual modeling efforts. So project that back in, make that part of the core workflow rather than editing 15 spots, deploying over here, deploying over there. Those are our big goals. There's a lot of workflow platforms. I'm clearly not alone in thinking workflow is important. This is just a shock and awe slide. There's too many of them. When you're doing the process of trying to figure out what your platform should be, you're inundated. These are all pretty small. Now let's do the big kahunas here. We've been exploring platforms pretty seriously for, I think, most of the month of February. There's Metaflow, Flight, Kubeflow, our good friend, MLflow, and we have an internal platform that's actually quite accomplished, but fairly small in scope. So MLflow, yep, I saw one of the comments related to MLflow. Logging, a very nice way for scientists to understand and model behavior and compare them. There's a number of teams using us inside of Zillow right now because it's so convenient and so well put together. Flight, great workflow system. You can express data workflows very nicely as well as your model workflows. Metaflow, I love their workflow syntax, their decorator syntax. It's a small, compact jewel of a model. And then there's Kubeflow, which is sort of behemoth with almost everything you can think of in there. Now, I hope no one's in the audience going, oh gosh, you're being mean to Kubeflow. Kubeflow is awesome. Okay, selection criteria. I was talking to Alyssa about this. The selection criteria is quite complicated. This is, I think, about a quarter of our selection criteria we looked at. We try to figure out all the different metrics and concepts we want to actually understand for our models. Selecting a platform. We went through, we actually looked at those different platforms. We did a little experimentation with actually deploying them and having some fun actually doing little teeny models and toy things, as well as studying the source code when we get a hold of it, and looking at all the documentation. We took a huge chunk of time to do this. I would have wanted to spend more. I'd like to do more bake-offs with let's try deploying larger, more complex models. But as you can imagine, burning a lot of people's time for more than a month got to be rather prohibitive. Our leading candidate is Kubeflow. So speaking of not actually being upset with Kubeflow, it really came down to and I'll do the really quick one, came down to the level of community support, big community, and the offering is very wide and vast, right? Flight doesn't quite have all the bells and whistles. I love Flight. Flight's my personal favorite. Again, Kubeflow guys, don't be offended. Metaflow, I'm a big fan of, but they don't really have a good Kubernetes story, at least not the last time I looked. So Kubeflow is our favorite. So let's go to Q&A. Okay, how was that for being succinct for once? Okay.
Yeah. Amazing.
Yeah.
I will clap. Thank you, Kevin. This was fantastic. For those of you, so I've seen a lot of people posting questions. If you still have a question that you want to ask, click on the little raise your hand thing, and I will unmute yourself or unmute you so you can ask it, so we don't go all at once. So who is, anybody? Okay, here.
Be someone brave.
Steve?
Thanks. So thank you, Kevin. My question is, what are the ML tasks besides Zestimates that are necessary for Zillow to really succeed in iBuying?
Oh, okay. This is a little complicated for the amount I can disclose. Let's see. Boy, good question. Very good question. When you stump the chump here, this is great. Yeah, so let's see what I can disclose here properly. Okay, so they have the valuation task, which is one of the central tasks, obviously. And one of the, I'll try to stick to that one for the time being because there's a bit of a minefield for me. The biggest difference from Zestimate there is that they have an inspection and fine-grained data about the home. So they should be able to actually do a much finer grained job of actually pricing that particular home with this particular idiosyncrasies. There's quite a bit of interaction during the pricing process that is tied in with the full system and the UX that I can't talk about. Yeah, boy, I'm trying to think what parts I can talk about in this process. Risk. They have an entire sub-team that models risk. What happens if the market turns over? What about capacity? What if we slow down in terms of how quickly we can turn over properties? Whole risk division. It's the entire sweep. Trying to think of the other areas. And then modeling user behavior. The whole gamut of behavioral modeling for purchase price. They have a whole strategy team. What is the right sales strategy? So modeling that. Which should our pricing strategy be? Should we be able to learn the curves and respond to those things? Now on the ground, it looks very similar in terms of the day-to-day activities, those sort of things. But yeah, those are the critical pieces that they have to model. I expect Open Door has the same thing. I can't believe any of the other people don't have the same kind of like underlying modeling regimes they need to actually accomplish. Steve, is that good enough? I can't get it beyond much of the detail of the proprietary pieces.
It's nice to hear some of the contour of it. And like, if you had to say roughly, like how is machine learning staffed at Zillow? And I apologize if this was the beginning of your talk. I joined a few minutes late.
Oh yeah. Okay. You mean like there's a numbers question there? Numbers. Okay. I think we're around 100 applied scientists. So it's a significant number. So if you look at AI Platform and say what's our total addressable market within Zillow, about 100. That's enough to be that there's a significant both salary cost, obviously, but also quality of living, quality of life for the actual scientists and getting stuff done. And then, like I said earlier, your modeling velocity is your business velocity. Those people are right in the center of the business velocity. We got to answer those questions as quickly as possible. I got to figure out if I make it too easy to experiment, if I break the bank that way. Like, hey, let's do Zestimates and let's see how it does for the nation in 55 different parameter sweeps. Whoops, whoops, too much money. Those kind of things. But yeah, my biggest goal is to make it very quick for those guys to experiment.
Thank you.
Yep.
Thank you, Steve. Patrick, you had a few questions. If you still have a question, it will be a great time to ask it now. Okay, Patrick is all good. By the way, Eduardo has been making an incredible effort at answering everybody's questions in the chat.
Good.
So, bravo. Thank you so much, Eduardo.
There's a series of Zillow plants in the audience. Good work. Yeah.
That worked really well. Daniel, if you still, okay, I see. Okay. Patrick has a question. Go ahead, Patrick.
Hey, so I'm kind of curious if you can talk about this, what the meta models look like doing the validation process for model rollover. Are they driven by sort of like business KPIs rather than like regional specific MAEs, or I don't know if you can get into this, but I'd love to hear a little bit about that.
Yeah.
Great talk, by the way. That was really.
Thank you. Yeah, I hope everybody enjoyed it, by the way. Yeah, so our metrics are dominated by the classic metrics about model health, accuracy, calibrating them. Mapping the top of the line business metrics directly to model performance is always a really interesting and complicated question. In a case like Zestimate, since we don't actually have a lot of interaction, like you don't click. There's not a lot of clicks on Zest, right? It's a feature of the page that drives you through. We can't get a lot of interaction that way in terms of like being able to model. Oh, if we do A/B, change Zestimate this way. That sort of thing. But generally, when we can, like any model I've ever worked on, Microsoft here, if we can tie it to a business metric, we do. This is very complicated. I don't have a lot to say about that particular point beyond just the general that it's mostly dominated by our internal model health metrics. Does that get close enough to what you're interested in?
Yeah, thanks.
Okay.
All right, anybody else? I have a question. Seems like I don't see any other hands. Actually, it's a question that Brian Hale was asking before he left, and he was wondering if Zillow might ever surface bits of Zestimate explainability to the end users. So people who are looking at the Zestimate for their own home or for other homes, is there any plan to surface what features went into that and what affects that?
Oh gosh. Oh yeah. No, this is. I have many favorite areas. This is one of my favorite areas. We currently use nonlinear models, which obviously are difficult to explain. So when that speed layer, for instance, people say, hey, guess what? I have 5 bedrooms now. Let's see what happens. Sometimes they get surprised where the price doesn't change very much. They're like, huh. So right now we can't reliably explain to anybody, why is it that when I add a room, nothing happens? Or something much less than I expected to happen. Like, shouldn't it be $20,000 more or whatever they're in their head? We're looking at explainability because we believe it's a great vehicle for trust, right? So, hey, in this region where you're at, it turns out for your particular part of how that home is valued against other comparables, rooms are generally worth this much. Or as you know, it's really more of an issue of saying the price is determination in terms of the explanation. So if you think of things like lime or tree shaft or those things, those are the things we're definitely looking at, trying to graft onto the system. The platform is interesting because if you look at things like Selden Core, they have Selden Core. Selden Core is a scoring framework in Kubeflow. It's also, I believe, we use externally, but so scoring and a model inference framework, as well as it actually can evaluate full-on scoring graphs. Okay, so that framework actually has built-in potentially outlier detection, and I believe they have Lime hooked up automatically. So, I mean, it's always a question about, in practice how well it works, but those are interesting approaches to actually, especially at the platform level, how to do that. But yeah, for Zest, we thought about it a lot, about trying to service it. When it comes to explaining how your house is valued and trust, we definitely think that could be a great thing to try. I'd like to get that in the next generation system and do explainability from the beginning for Zestimate.
Fantastic. Thank you. And I think Brent's iPhone has a question.
Yes. I think he's muted.
I don't know if you can hear me, but I'm interested in graph databases. And how do you feel about them as like a storage medium?
I missed the said something database is all I heard.
Yeah.
Sorry.
How do you feel about graph databases?
Oh, graph. Oh, yes.
Like Neo4j.
Yeah. Okay. I would, that's right. I am very excited by graph solutions in general, to this space and learning off of graphs. We've had some, we did do some research on graph neural networks for evaluation problems. It does seem like a fairly elegant and natural solution to the work. We have not done any serious looking at that recently, as we're trying to more or less, mostly I'm focused right now on trying to transition to a new framework so we can do experimentation against such solutions. Unfortunately, I don't have a strong opinion on Neo4j. I haven't studied it too much. But closest I can get to is the graph neural network solutions for trying to actually do evaluation in a neural framework rather than our current nonlinear tree frameworks. So, good enough, Brent?
Yeah, thank you.
Yep.
Yeah, that's good.
Anybody else has questions?
Patrick!
Thank you. I have one more question. So I also recently bought a house, and it occurred to me, and this might be anecdotal, but it seems as though the actual sold price is quite heavily weighted, especially for nearby comps. And in our case, and I'm sure many others, there was a pretty heavy round of negotiation that, so the buyer actually ends up paying sometimes substantially less than whatever the sold price is.
Mm-hmm.
And presumably, at least I can't think of a way, but perhaps you guys do have a way of estimating that delta between the list sold price and what the buyer, you know, say there was like, you know, X% of negotiated back pay. So is there an attempt to estimate that delta? And yeah, I guess I'm just wondering if that's done.
Yeah, as you can imagine, for Zillow offers, that'd be amazingly important stuff. For Zestimates, interesting, trying to get a hold of that data turns out to be really hard. Is the biggest issue. And I'm not qualified enough in the understanding the industry overall, but there's definitely a strong, seems like a strong preference to keep the document, to keep the piece that's formally documented being that agreed upon price without all of the takebacks or other adjustments to the price. And I think there's a bit of a strategy question that's lurking in there that has a little less to do with modeling, a little more to do with how people strategize around what pricing should be. Now, if we could ever get a hold of that data reliably, we'd love it, because then we'd model effectively, talk about net, like, you know, and then there's a whole bunch of situations that I'd love to model someday that's related to this, which is like, so we show you this estimate. If you're a seller, what does your net look like probably? And it's a pretty hard problem also. So again, modeling this sort of the mirror image of this, it's like, hey, what do you think is going to happen here, right? What is the average case? Very hard to model problem though, because this is getting into that question of large scale versus the individual variations in your home. Do you have a particular problem with that home? So anyway, we definitely are interested in doing that if we ever found a really reliable data feed for that. It's definitely an important issue that we'd like to get, because that goes back to the primary mission of Zillow, which is like, can we tell you what to expect when you're buying the home? Can we tell you what to expect when you're selling a home? Not only the value, but actually, hey, yeah, you know, the real estate agent tells you a list for this, but look, it might actually have this kind of underlying sort of closing set of issues or costs, etc. So, yeah.
Thank you.
Thanks, Patrick. Rory has a question on data quality,
which is an awesome set of issues, actually. Yeah.
Rory, do you want to ask the question?
Come on, Rory, I want to hear.
I always feel strange unmuting.
Yeah. Oh, yeah, someone.
Oh,
exactly.
So Rory is asking me if I could just ask the question that he added to chat.
Okay.
How do you manage data quality and monitoring over time?
Oh, yeah. So I thought this was one of those fun questions. Yeah, no, and this is a huge issue for us. So as I mentioned earlier in the talk, the layers of data processing that come before I even start my day are amazing. And all those layers are monitored to different degrees. And we actually have, I guess you'd say, and there's never enough monitoring of these data quality issues. For us, I'm sorry to say, most of our big data issues that show up at the metrics I talked about, state, county, and national level, national especially be hard to hit, are showing up by perturbations that are fairly large in the Zestimate system. Over time, we keep adding metrics around some of the early data feed questions. Like, we've had a situation where, like, we put in a monitor for how many homes are coming in counties and how much is changing over time. Because we do see situations where we've had situations where a data feed from some county, they've dropped 60% of their homes. And we're like, we're fairly certain they didn't lose 60% of their homes. But this is endemic to a stack like this, right? With these very complex stacks that have all this data. So we're talking a lot with our data engineering team about, okay, and our data engineering is all over this. How do we get much more systematic testing at all levels? And it needs to be automated, it needs to have outlier detection, all those things sort of built in so that, and then that allows us to start to get into the point of talking about what's our data contract? When can we alert reliably? All those things. If you've ever been in a system that has alerting that's too tight, then you spend all your time basically wanting to, eventually you get to the point where you're like, you have alert fatigue and you're like, I don't want to respond by beeper anymore. Beeper, where that came from. My phone anymore. I'm a kid of the 80s, evidently. So yeah, it's a very common problem. And I know our data engineering team is just all over this right now. They're working very hard to build a framework. And remember, earlier on the talk, I talked about the ZG data platform. That's a lot of it, putting a ton of effort. You combine it with compliance, which requires data lineage, all those things put all together, and you have a very rich set of tooling that people like my science folks are going to use to actually get Zestimate to be even that much more reliable and understand its behavior. So I talk about debugging a particular Zestimate. The idea that I can actually go back and see an alert. Oh, geez, I see. Yes, it turns out this part of Los Angeles is losing bedroom counts. Okay, now I know what's going on. I no longer have to do the chase my own tail. Very common in systems like that. My experience at Microsoft over those like 17 years, same deal. But yeah, so that's where we're at. I wish I had an awesome, amazing system. It's pretty darn good now, but I'm really looking forward to data engineering teams' next set of efforts.
Wow, sounds great. Thank you. Andrew has a question as well.
Hi, I'm curious if there's ever been a case that you know of outside manipulation against the Zestimate. You know, as a buyer, there may be an incentive to try and manipulate it lower to negotiate a lower price on buying a house. Or as a seller, you may want to manipulate it higher. So I was just curious if there's ever been any sort of outside manipulation caught. Well,
okay, luckily none that I'm aware of. We also work really hard to say something. It's one of our taglines. It's a starting point. Zestimate is, you really have to, it's a starting point for how you understand the value of your home. We just got through talking about a lot of the factors that affect the value of your home. Now we try to be really careful to watch for people to actually manipulate their home values. And so I said, one of the interesting questions comes down to when folks, if they play with, actually change the bedroom count. People, my general experience, my observation, which is more of a personal observation, is that people seem to be generally pretty ethical about not, like, for instance, playing with their room count in their house. There's also an interesting thing going on. They're like, if you have an addition to your home that wasn't permitted, like you didn't go get a permit for it, they're afraid to actually list that kind of fact on Zillow as well, because they have a tendency to think that, well, perhaps the government or the county is monitoring it, or any other situation where they may have a material fact that might change. They're a little reluctant to put it there because they're worried that that we're like, this being scraped or crawled by some government entity or anything like that. That's not the case that I'm aware of. We have no relationship with those people at all, but it makes sense psychologically. So there's a lot of interesting issues about how people perceive their home facts and what it means for values. But I'm not aware of any systematic or even sporadic manipulation of the price.
All right, thank you.
It's something to watch for. Yes.
Looks like there's one more question. Patrick, do you want to ask the question?
Sure, why not? Can you reliably identify houses that are going to be listed that aren't yet listed but may be listed in the near future just based off of search and updates on your site? And are you going to be using that to be able to maybe jump the market at all?
Yeah, well, let's see. Here's an interesting question. Can I reliably do it? That one, I even if I knew, I wouldn't answer that one particular, because I think that's probably getting into that is an awesome question, and it's extremely salient, which I'm not going to answer. Now, are we looking at that? Of course, we're looking at that. Those kind of predictive situations are bread and butter for what we're going to do. Virtually every place we're talking about, these models that talk about these actions are taken. I think my colleague Rsqrd is actually on this. I think he was listening to this. His team on personalization and other teams are looking at these models for predilection and for like I said, almost any of the activities that lead down funnel for us. It's an extremely important area. Whether or not we do it well, hey, perhaps when we start hiring again, we'll you can come on over and
Fair answer. Thanks.
Yeah.
All right. Any more questions? Okay. Well, Thank you, Kevin. This was incredible. I consider myself an ML platforms nerd, but I learned a lot today. This was really awesome. And I hope we get a chance to get your slides so I can share it with everybody. And I think it could be a small book on ML platforms at scale.
Yeah, super. Yep. Thank you very much.